Hi, and welcome back to Colleen Devs Tech, and today's problem we're going to solve is 21 merge 2 sorted lists. And in this example, we are given 2 linked lists and they're both in ascending order, and what we want to have as our output is a merged linked list also in ascending order. And so I have it drawn out here, and basically what we want to do is find each node or look at each node and compare if it's equal to or less than, then we're going to have that merge into our linked list. We're going to reassign it like that. Then this is going to be like this. And then this is going to be like this. Oops. And so forth until it looks like our merged output. Okay. So the way that we're going to do this, we're going to need some extra help from a ghost node. And what the ghost node is going to do is going to hold our beginning pointer, so we can later on return it. So what this is going to look like is that we're going to have 2 variables. We're going to have a dummy node and a current node. The dummy node is going to hold our beginning node, and then our current node is going to grab. It's going to grab each node and bring it along. We're going to move our current pointer, and our pointer is going to grab the next, just like that. I'm going to code it up, and we can walk through the code together while I draw out the process. So let's say, we're going to need our current node, current and our dummy pointers to be set to our empty list node. And if you're wondering what this list node is, it's actually given to us in the problem. We have a class node here and it's defined, but we don't have any value, and it's not pointing to anything. Okay. So our dummy node looks just like this, and we have the current and the dummy pointing to this empty node. Okay, so what we're going to do next is we're going to say while list 1 and list 2 exist, while these 2 lists exist, we're going to look at each one and compare it to each other. We're going to say if list 1 dot val is less than or equal to list 2 dot val, then we want to have our pointer at list 1. Current equals, or current dot next equals list 1. So let's look at what this looks like. So while we have list 1 and list 2, while these 2 lists exist, we want to look at list 1 and list 2. If list 1 and list 2 are equal to each other, or if list 1 is less than list 2, we're going to add that to our list. So we're going to set current dot next will be list 1 because the condition is true. So this is actually going to be brought down just like that. And then we also want to move our list pointer over to the next. So that is going to be written out like list 1 equals list 1 dot next. We've moved our pointer over, and then this is taken out, but we need to move our current pointer over. Just like that. And we can write that out like this. Current equals current dot next. just like that. So now let's look at the next. So we have list 2, in this case, is less than list 1's value. So this condition won't run. So we have to say, just before this current.next, we're going to say else current.next is equal to list 2. So we're going to say current.next is list 2. So now we have a pointer at list 2. What this is going to do is bring this down. We have a pointer at it. Okay. And then we're going to say list 2 is equal to list 2.next. And then this pointer is going to be pointing to the next. And then now we have this current.next. So this is going to move our current pointer to the next. So now we're going to go through this again. If list 1 is less than or equal to list 2, which in this case it is, we're going to say current.next is list 1. So current.next is 1. Bring this down. Bring that down. We have to move our list over. So weird. Bring that down there. There we go. And then now we look at these two. List 2 is less than list 1, so we've got to move this one over. There we are. And then now we look at the next one, and it says current.next is list 2. So current.next is list 2. So we have that down there. So I'm going to move it down here. And list 2 is .next. Just like that. Now these two are equal. These two are equal, so the first condition is gonna go through. So we're gonna say, well, keep forgetting to move over our current. There you go. We're gonna say current.next is list 1. List 1.next, which is going to be nothing. Okay, and then we're moving our current. Then lastly, current.next is going to be list 2. And we're moving our current here. Okay, so this is what it looks like. Now, in the case that we still had more nodes in our list, let's say that list 2 still had some additional nodes, then we would return the rest of the additional nodes looking like this. And then also similarly, if list 1 still had nodes and list 2 didn't, we would return all of list 1. So the way that we write that up, in the case that we've exhausted either one of these lists, would look like this. We'll have another if statement. If not list 1, if list 1 does not exist, then we return everything in list 2 because it's already linked. So we say current.next equals list 2. We're saying current.next is list 2. And that brings it down here. It links it. And then similarly, else current.next equals list 1. If list 2 had, but list 1 had, but list 2 didn't, then we would add these. And all we have to do after that is we want to return our dummy dot next. After all of that, now that we have all of our nodes merged in the proper place, we want to return this dummy node so it's taken out of the list like that. So we want to return this, and so we say return dummy.next. Okay, let's run this and see if it worked. And perfect, it is accepted. The time complexity of this is OM plus N because we do have to iterate or go through the different nodes. And the space complexity is O1 because we didn't have to, it didn't take additional space. And yeah, if you enjoyed this, if you enjoyed my drawing, please like and subscribe. And if you have any comments or anything like that, please let me know. And until tomorrow, thank you.